All right, good afternoon, Saturday afternoon. I want to walk through Hibbelers' way and Estwicks' way of dealing with a motor that's drawing in a rope that's in some pulley configuration. And as the motor draws the rope, you've got some length of this rope defined. And you take the derivatives to get velocities, and then you can figure out the velocities of weights. Common problems in this section of Hibbler. So let's walk through that, and hopefully it'll be clear. So here's the setup. The blue line, of course, is the rope. Hibbler would have you define a point here. We'll call it B. And he will give you that the velocity of the, well, no, he may or may not call it velocity. He'll say the motor, and, somehow does something, and we'll call it 2 feet per second. So this motor draws in at 2 feet per second, which is a velocity. He may also tell you that the motor causes an acceleration of, some number of feet per second squared. Just deal with it like you would deal with any other motion. But so the question is, how do you deal with this when you set up your problem? And we're going to do the same thing with the datum. So we'll set up a datum here. I'm not going to set up a datum at the bottom. And so I'll just need this one datum. So this is going to end up being the distance to A. And then we'll call this, or Hibbler would have you call this, the distance to B. And then effectively, so you draw out your equation. Length is going to be, as you follow it through, 2SA plus SB. And then the time derivative, so in his world, length, and he's right, because in this sense, he reckons that the rope ends right here. And this is all out of play. It'd be just like if you had a hand gripping this point and pulling. So you go ahead and take your time derivative, and because he defines the length as from the ceiling to B, clearly that length is constant, so it's fair to say the time derivative would be 0. 2 times velocity of A plus velocity of B. Now what we know is the motor is pulling that rope at 2 feet per second. So we just plug that in here. B is going to go down, assuming the motor is drawing the line in. The motor could be letting the line out in this case, but in this case, it's drawing it in. So now velocity of B just becomes 2 feet per second. So that's how he does it. So your answer, of course, is that A moves up half as fast, and you go from there. So what I don't like that, because in my mind that rope is, I guess I play mental games too, but the rope that's in play is getting shorter, if you ask me, because it's getting drawn up into the motor. And so if I have if I call this H, draw my datum, same place, call this H because that's the same. The height's the same. And then same over here for SA for that datum. So I have the length as H plus 2SA. Time derivative of this, H is a constant. The distance from this pulley to that motor is a constant, so the time derivative of H is 0. But the time derivative of the length, the overall length, it's now getting shorter by however much that motor draws it in. So dl dt for me is going to be 2 feet per second. So, and then the time derivative of SA is SA. 2. So that's really it. It's how do you define your system, right? Where's the boundary of your system? What's in play and what's out of play? He takes everything out of play from the motor, and then the motor is just kind of nice to know about. That's kind of why I like this, because I keep the motor in play and the motor's effect is to shorten the rope. Actually, I did this wrong. This would be minus 2 feet per second here. Because the length is getting shorter, which makes sense because over here, his 2 feet per second is on the right-hand side of the equation. Mine's on the left, and so it does need to be minus to be accurate. So anyway, don't get hung up on that. But that's simply how I see it and how Hibbler sees it. You're free to use whichever method you want. They will both give you the correct answer. So no fear there. It's not like you have to define ahead of time what truth is. So, okay, I'm going to break now. If you have any questions on this, shoot me an email or ask me on Tuesday. We will have a test on Tuesday of the remainder of Chapter 12, stuff we haven't covered yet. So it may be a rope problem. I haven't decided yet. I haven't read the quiz. So, all right, take care, guys.